Okay, so let me answer this question you asked about section 10.3, how to do it when you're not doing it by hand, how to do it with the StatCrunch or some technology. So before, though, I do that, we've got to remember the concepts that you obviously know how to use because you said you're doing the smaller sets by hand. Um, and that is that we're trying to create this regression equation that describes the relationship between the independent variable x and the dependent variable y hat. And it's going to be a linear equation, and there's some requirements before we can start to assume that that equation is going to actually fairly estimate the pattern. So let me skip through a few of these. By the way, I'm just sliding through the PowerPoint to grab some good screenshots for this, and you can go back to the PowerPoint as well. Let me come here. Okay, so some requirements. The sample data must be paired, and we're not trying to trick you with any of these. They already come paired, and they're making that clear. But you should be running a scatter plot first, meaning take this paired data, let the horizontal axis be x, the vertical axis be y, and plot a point for it for each piece of data. And it's paired data, so you should get a bunch of ordered pairs that make a bunch of points and inspect it to see if it's a straight line. Okay, and then of course remove outliers as they affect it. Then we can go forward with the creation of the equation, and it can be meaningful. So let me just do the first example. There's an example in the PowerPoint also. Let me come over here and do the first example that I saw in the homework that might apply to what you asked. This number 4 from section 10.3 has quite a few ordered pairs there. And so in StatCrunch, here's how you do it. You open it in StatCrunch, or you can type it all in. You run a graph, check the scatter plot, and let the independent variables be the first column, x's, the dependent variables be the second column, and then display the points. So really all you have to do is go hit graph, scatter plot, x and y for the columns, and they're already labeled that way. And then it's already going to by default choose points. You don't need to change anything else here. I'll show you what you get. And this actually will be graphed for you when we find the equation, which is what they're actually asking for. But I do this first because I want to, if I wasn't doing it by hand, I would do it with this. Because I want to see, does this have a tight or a reasonable linear pattern? And it doesn't. Actually, it looks more quadratic. If you see that, follow the pattern down. But let's argue that, maybe it does have a linear pattern, and we're going to move on with it, and we're going to see, what the regression line would look like. So I'll go ahead and close that. By the way, StatCrunch has been behaving weird, as some of us have already found out. So after I close that, if I've done any of these functions up here, I go ahead and just click on a square anywhere, some open or a cell, I'm sorry, some open cell. And I say open, but it actually can be any of those as well. Okay, and then I do stat, regression, simple linear, because that's what we're assuming here, that it did have a linear pattern. And then we're going to see what the regression line would look like. So simple linear. We're going to choose x and y again. And this hypothesis test we're going to leave as it is here, and we're assuming, and the way we've been running this is we assume that there's no correlation, right? And then we test that hypothesis, right? If there is no correlation, then the claim is that there's some correlation. It's either less than or greater than 0, right? So if rho is 0, we leave this here, and then the alternative would be, because if this is not true, that there is no correlation, then there's some correlation, right? Either less than or greater than. And that's what not equals is telling us. So I make no change there, essentially. My level of significance, I'm keeping it stronger rather than weaker. So my alpha here is 5%. Anyways, no change there. I'll actually let this graph as well, and this is what I stated just a second ago, that it'll show you the graph too. It's just on the second page. I'm going to graph the scatter plot with the fitted line plot on top of it. And that will help me answer other parts of the question. And there's really nothing else I need to change. So again, I hit stat, and then I chose regression, and then I chose simple linear regression. I put in my x and y, and that's all I have to do. So hit compute. And here it has that we're treating the dependent variable as the y. Good, we wanted to. Independent variable is x. And we get the equation. Y equals 3.0 as our intercept, and 1.3, and I should be rounding to 2 decimals, but since the 2 decimals, and I'll just scoot it over here, that are given are just 0, 0, 0, you know, so it's just going to be 0, 0. I probably could just get away with just typing a 3 for that matter, and then 1.3 for the slope. Okay, so we'll check that answer. Great, there's our regression line. Does it really mean anything? The scatter plot that we got for this can be seen, well, I already showed it to you, but can be seen if you, as I said earlier when we hit stat regression, simple linear regression, and I said to leave that one line marked so that it would graph the regression with it, or the scatter plot with the regression line. Here's what we've got. So the scatter plot's there. Let's see if I can enlarge that a little bit. Let's see if I can make it, the dimensions look similar. And you're going to look through the fitted line and at the blue dots, and you'll see we've got something like this here. So there's our scatter plot. And then it says identify a characteristic of the data that's ignored by this regression line. So great, we've got this equation right here, right? And we've got this regression line that is the graph of that equation. But does it mean anything? Well, let me come down here. The data doesn't look at what our eyes look at to find out if in the first place it even had a linear pattern. Like even this choice A of the multiple choices here has, you know, a grouping that looks like some sort of a linear group, right? It's not fitting some sort of other shape. Similarly here, but this one is looking, if we had more data we'd be able to see, it's looking kind of quadratic, and that is what the equation ignores. It's just running the calculations. We're finding that, and we didn't even look at this, but we're finding, I'll go back to it, the Pearson R, the correlation coefficient, we're finding that it's very strong. It's a very tight correlation. Well, it's a tight correlation, but it's not a linear correlation. And that's what we're trying to work out right here with these linear regressions. So yeah, tight correlation, but not linear. By the way, oh, let me finish answering the question, then I'll make this last comment because you might not want to listen to it. So there is no trend in the data. There's an influential point. No, it's pretty much all. The data is, okay, so the data has a pattern that's not a straight line. I'll go with that. And I know I'm answering a little bit more than you asked. You just wanted to know, or you only asked how to run the equation here. But I want to look at this correlation coefficient right here. And I'm going to go to the table. This is from the foldout. This is part of the approved notes, of course. And by the way, this is grouped by chapter, so it's really easy to go, oh, here's chapter 10, here's the linear correlation / regression, and this is where I can look up the pieces I need. It is interesting, though, that in this foldout, it doesn't have the other representation of B1, which is basically our slope, right? It has this morph looking one. I always think that it looks like a slope on steroids, right? Because normally a slope is the change in the vertical, the change in the y's over the change in the x's, change in the horizontal, the rise over run, but doesn't it look like it's kind of like the same idea but on drugs? The Triola Stats card does have it though. It's just not organized by chapter, it's organized by subject. So you come down here. Hope this isn't going too fast. Okay, down here to correlation, regression, and prediction intervals. Okay, right here, regression. And you'll see that they have both versions. They have B1 is R times S sub Y over S sub X. That's the sample standard deviation of the Y's and over the sample standard deviation of the X's. And that's, for me, an easier calculation to run if I'm, well, what am I saying? I mean, the whole thing's easy because I'm letting technology do it, but I could have run the summary statistics and then just pulled those two things out of it. So it's really, I don't know, 6 in one, half a dozen in the other. It doesn't really matter, I guess, but just wanted to point out that this card doesn't have that stated, whereas the review card does. So it's good to be familiar with both. Okay, so the correlation coefficient. All right, so if I was using a very strict level of significance of 1%, since my set has, let's see here, it has 11 points, then I would come down here to n is 11, and I would be looking for the R value that is greater than, assuming that my hypothesis, my null hypothesis, is going to be rejected, and it is going to be rejected if the R value is greater than this value right here. And even if I was using a smaller level of significance, like 5%, then we would be here. And sorry, I say smaller level of significance, which is what I mean is a larger confidence level. Okay, so no, I don't mean it like that. I'm sorry. I mean a larger level of significance, but a smaller interval, less tight. Anyway, even if I was using that, I'd still be well above because mine was 0.94. Okay, before I lose the point that I'm trying to make, everything looks, just by the calculations, everything looks fine, right? I've got this line, and I've got this really tight correlation number for a correlation coefficient, but it's all pretty meaningless if I'm doing something that's not actually calculating or it's not actually describing a pattern that's linear. In fact, I'll go back to our slides here and say this another way. Right here with the flowchart. Is the regression equation a good model? Right here, the regression line graphed in the scatter plot shows that the line fits the points well. Come over here. No, it doesn't. And I'll show you that again. So the regression equation is not a good model. In which case, regardless of the value of x, the best predicted value of y is the value of the mean of the set of y's. So see here how this does not fit our scatter plot, because our scatter plot's not a linear plot, it's a curve, and it doesn't fit it. So we would actually have just used, if we were making some sort of a prediction, we would have just used the mean of the y's. I hope that helps answer the question. Hit it one more time. You're going to punch stat, regression, simple linear, choose x, choose y, choose your independent variables, choose your dependent variables, and you make no other changes here if you're just trying to get the equation.